the Sustainability Management Master's Program, you're answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
Oh, here we go. Okay. Yeah. Okay. Got it. Thank you. Yep. So we've been working in this area for a couple of years now and just brought Perry on this year to lead the initiative. And renewable natural gas is basically a term that describes upgraded biogas. And it's methane. It can be used any way that natural gas can be used. And it's an alternative to fossil fuels. So basically, we're taking carbon that's already in the biosphere and recycling it. What you see here on this picture is actually a municipal digester for a biogas project in St. Pete, Florida. And you can generate biogas from a number of different areas, including solid waste landfills, digesters at water resource recovery facilities. That's what we call water treatment plants now. Livestock farms, which is what a number of our projects are right now. And then food production facilities or organic waste management operations. So this would be anything that has like a concentrated organic waste stream. So basically, the content of your gas can vary based upon your feedstock and your generation method. So what you're seeing here is two of the common sources for biogas. One is landfill waste, and then the second one down below there is anaerobic digestion, which can be animal waste or food waste or any organic waste for that matter. But biogas from organic sources made through anaerobic digestion generally contains about 45 to 65% methane. So you have to treat that biogas to remove a number of constituents, moisture, particles, contaminants, and then other gases such as carbon dioxide, oxygen, nitrogen, and VOCs. So the goal of the treatment process is to get the methane content up to around 90% or greater. And then you can produce RNG compressed gas and put that into your natural gas pipeline. So this slide just basically shows a couple of different processes for two of the more common sources of biogas. So on the left-hand side, we have landfill gas treatment stages. And on the right-hand side, we have anaerobic digestion. You can see that looking at the end uses, they're basically the same. It's heating, electricity, or other industrial uses. But if you look at the process, it's a little bit different. So when the gas comes out of the landfill, you have to go through what they call a knockout pot, which basically removes moisture, and then the gas is filtered and may be flared to get rid of some of the contaminants, some of the non-methane gases. And then you go into a secondary treatment process where you have moisture removal, taking out the sulfur. You then compress that, and that's your biogas. And then to get to RNG, you have to go through an advanced treatment process. And that's basically to get to the quality that you can put in the pipeline or use for vehicle fuel. So we're going through a process of removing a number of the gases, carbon dioxide, oxygen, nitrogen, VOCs, then you may have to flare some of the contaminant gas, but then it can be compressed and used as RNG. So on the anaerobic digestion side, you can see that a little bit simpler. We get out, we remove the moisture, flare contaminant gas, go through the sulfur removal, compress that, and that can be biogas. And then we have a CO2 removal step to get to RNG. But with the digester, you have the digest state, which then can be used as a number of things. So you have liquids like ammonia that can be used as fertilizer, solids that can be added to soil or used for animal bedding or other uses. So that's kind of the overview of the two basic processes. Perry, have I missed anything here that you want to add?
I would just add, it's probably interesting to note that with landfill gas, unlike anaerobic digestion, you can go through the planning process and within 12 to 18 months, you can have an operational site on hand. However, with my apologies. However, with landfill, it takes about 5 to 10 years before the organic matter decomposes enough before you can even develop the land for use and extraction of viable biogas. So longer process, and naturally with landfill, you have more contaminants associated with that.
Go ahead, I'm sorry.
Go ahead.
Yeah, is there any way of accelerating the biodegradation?
With landfill, no. Generally, it's a natural breakdown of organisms through the oxygenation process. But with anaerobic digestion, yes. There are two methods. There's mesophilic and there's thermophilic processes that you can incorporate. Higher temperatures, usually between 120 to 140, is thermophilic. More costly to implement, more costly to operate, a bit more complicated with the design. However, you end up with biosolids that are considered A class by the EPA and can directly be land applied over fruits and vegetables. It's used as fertilizers, and there's minimal concern for human health associated with that. There is a secondary method, which is mesophilic, and it's usually lower temperatures, more common in the industry, lower digestion process compared to thermophilic. But then it produces class B biosolids that can't be necessarily just land applied like fertilizer. Right. So those are the two. Hopefully I answered your question.
Oh, absolutely. Thank you.
Yeah, and we're looking at doing some research on some pre-treatment for the animal waste to actually to increase the gas production. So we're looking at finding some of that research in the upcoming years.
Yes.
Be a nice technical differentiator for us.
And it's important to note in anaerobic digestion, moisture and pH levels definitely yield different amount of methane through the process. So tweaking those parameters can improve your process dramatically. With landfill, you pretty much end up with what you end up.
Right. And you'll see, I think it might be the next slide. No, it's coming up, but in one of these slides, you'll see how the landfill gas has been going on for some time, but we're really seeing a big uptick in this animal waste anaerobic digestion over the last few years, I think since like 2018. So there's a number of applications and benefits associated with RNG production. One of the things you can do is produce green electricity, so non-carbon fossil-based fuel that burns in an engine to create electricity. You can produce bioproduct feedstock, such as plastics, makeup, diesel, and other chemicals. There's roughly about 2,200 large U.S. wastewater facilities right now that produce about 4.7 million dry metric tons of biosolids, and of that, about 4.2 million were disposed on the land. So there's a lot disposed of using land application, landfill, or incineration. I'm sorry, those three categories. So, Perry, were you going to add something to that?
It just goes to show with population growth that we have enormous amount of opportunity here to capture those solids and utilize them in a fashion that limits land application and also generates renewable resources for us in the energy sector.
Right, and it's not just the solids. The EPA greenhouse gas data reported that the greenhouse gas emissions equivalent in the US was about 1.2 million metric tons of CO2. So, to meet that goal of reducing that by 40% below 2005 levels, a large sum of that greenhouse gas volume would need to be captured and could be used for greenhouse gas production. And the EPA's estimating that by 2030, roughly 10% of gas contained in the US will be from RNG. And many of the products derived from petrochemicals could be supplemented with biomass-driven materials using this process. Anything else you want to add, Perry?
I think that sums it up. There's a lot of opportunity, without a doubt, and with our net zero targets and goals to 2030 being the immediate goal and 2050 achieving net zero, we need to utilize every avenue that we can, and recycling methane and other carbon products and reuse them instead of releasing into the atmosphere.
Yeah, so this is the slide I was referring to a second ago. So you can really see that there's been some really significant increases in ag RNG, starting really going back to about 2018. It's really started to pick up. And there's some state and federal renewable energy policies that are the main drivers. And we'll go through some of those in the subsequent slides. And then also in 2022, the Inflation Reduction Act, or the IRA, supported the viability of future investments by providing some financial incentives. But this slide just shows RNG projects going back to 2005, and you can really see that pick up here in about 2018 with more of the ag RNG projects coming online.
Fun fact to add here, Dave, is about 9% of methane emitted into the air is from animal waste and manure. So it's a large source of our methane emissions into the atmosphere. And with that also a great amount of opportunity to capture that methane, a large sum of methane. And that's why we're seeing an uptick in particularly ag RNG projects. Initially, there's a large source of methane there, but now we're also seeing a shift to using other forms such as biosolids, co-digestion with food waste and animal waste as well.
Right. And a lot of these ag RNG projects that we're seeing are at dairy farms. And right now the sweet spot seems to be, anything over 5,000 head of dairy cattle is pretty much makes for a viable ag RNG project. And we're hoping that with, future technological improvements and potentially even more policy drivers, that we can drive that number down so that we can have even more of these projects operating.
Yeah, Dave and Perry, what kind of infrastructure requirements do these things have? Are they really heavy on infrastructure? Because I'm thinking of smaller CAFOs, those smaller, cattle feeding, those dairy farms that you're talking about. That's small, small and marginal farmers. Can they take advantage of this and basically, generate more RNG from their, holding cells?
You want to take that, Perry?
Sure, absolutely. That's a great question. Thank you for that question. Originally, we were seeing an uptick in larger farms because of the viability and the amount of manure that they were producing. As those contracts, and yes, there are contracts associated with animal manure, as those contracts have become more scarce, we are seeing regionalized facilities developed where multiple different farmers are feeding into that regional RNG facility and then taking a share of the production. So absolutely, there's still opportunities for smaller farmers, dairy farmers, and participants in the space to partake in the RNG development. It's just a smaller share if it's a regional facility.
Okay,
And one of the main pieces of infrastructure you need is really a gas pipeline, right? So you have to have some sort of offtake agreement with a gas distributor who, and then you have to figure out a way to get the gas into their lines. So that is one of the main constrictions, I guess, or limitations to these projects. The actual infrastructure for building the digester is basically a big tank. So it's not really that infrastructure intensive in terms of the actual treatment process. There's some gas conditioning on the back end.
Right. Usually they're skid mounted and they take up very little real estate. Mostly the space is dedicated to the tanks associated with anaerobic digestion. I think as we also have seen that most of these farms are in rural and remote areas, that particular problem of being close to a pipeline infrastructure has created a solution. And we're seeing many companies call themselves virtual pipelines, and essentially they're logistical trucking companies that take compressed renewable natural gas and deliver it to an injection site. So we're also seeing an uptick in that market as well. And it's certainly resolving the issue of being close to a pipeline or pipeline system.
Okay.
Yeah,
Yeah, because last year, like our students got an opportunity to work with Dairy Farmers Association. It's basically like, again, a large cooperative, like, and came to know like most of the time, small scale farmers, like dairy farmers, they are afraid of like making investments on infrastructure,
right.
you know. And so that's why, like, again, I thought that like how readily are they going to be like, like involved in this kind of a project, which is obviously extremely green, and the ROI should be really good, like in the next few years.
We've seen a variety of situations that we've known some farmers that have had the capital to fund these themselves. But we've seen other farmers that have worked with investment firms, like Vanguard Renewables is one that plays in this space. And then there's also there's companies like Clean Energy that have teamed with BP, and they basically develop offtake agreements and find ways to capitalize these projects for farmers. There's a number of ways they get funded.
Correct. There's variation in the commercial agreements. I believe that now the main focus is around the manure and the contracting around manure and feedstock. And typically land is leased from farmers. Developers come in. Developers could be independent developers, or they could be directly energy companies and utility firms that come in and provide the capital for the offtake. And then they're providing a percentage back, similar to royalties around oil and gas leases.
We're getting ready to bid on one right now that's kind of interesting, where the city of Atlanta wants to do a biosolids treatment, and we just put an expression of interest in for that. And we're actually teamed with Southern Company Gas, which is the utility, and it's they're very interested in getting that gas. And when we talked to their director for renewable natural gas, they said, any project in our footprint, any RNG project in our utility footprint, we're interested in developing, and it's part of our ESG commitments. It's not a financial driver. I'm sure there's a financial component to it, but the main driver is meeting their ESG goals.
Yeah, that's a great way of promoting this.
Yeah. All
right.
Okay, let's see where we're going. I got to reduce this.
I believe we skipped one, Dave.
Did I skip one?
I believe so.
Yeah. So you want to talk to this?
Absolutely. Some of the benefits of RNG in comparison to other renewable energy sources. Anaerobic digestion and biogas are not subject to weather or seasons, unlike wind and solar that are dependent on wind patterns, seasonality. If the sun doesn't shine, you don't have solar power. It's a 24/7 operation. So as long as you have feedstock, and that feedstock is typically generated pretty consistently on farms, municipal waste facilities and other industrial facilities, you can pretty much count on generating biogas and through that developing RNG. Because of that, it's considered a base load renewable energy, meaning it's consistent in its production. And it's not necessarily used as a supplemental energy form, but it can be used as a primary energy form. And in many cases, we're also seeing that biogas is used and utilized to create electricity. And during peak hours and peak time, or depending on seasonality, whether it's a cold weather front or extremely hot weather days, it's used to dispatch power into the grid system for maximum dollars per kilowatt hour. One of the benefits of utilizing biogas compared to its counterpart in solar and wind is that you can also store it pretty cheaply in comparison to the power that is stored in large batteries from wind and solar to dispatch to the grid in high peak hours. So with that, overall, it's a cheaper project. It takes less footprint. The regulations associated with permitting are easier, and the value to monetize on the project is greater.
Thank you, Perry.
Absolutely.
So some of the other benefits of RNG over other forms of renewable energy is it can be used as a primary source of revenue for producing green electricity. So that is one of the primary sources of revenue, is selling the green electricity or the RNG. But it also has secondary. I'm sorry. Oh, sorry. Secondary sources of revenue, which can include like tipping fees for waste dumping. So you may have like a like in the case of a regional digester, you could have people pay to dump their waste there. You can sell some of those secondary products, such as carbon dioxide, the fertilizer, which is ammonia, or animal bedding, fiber. And then capturing the biogas can reduce greenhouse gas emissions for industrial facilities and result in carbon credits. And we're going to talk a little bit more about those that can be sold in the cap and trade market. So Perry, do you have anything you want to add to that?
I think that pretty much covers it. The big takeaway here is, as Dave mentioned, with other forms of renewable energy, such as solar and wind, you have one source of revenue, and that's the power that you produce. With RNG, in addition to the actual fuel that you produce, which is RNG, and the conversion of that potentially to electricity when it makes sense, you have secondary sources of revenue that can be very viable to the project and to the rate of return on your project. Right now, we're seeing a shortage in carbon dioxide, actually, that's used, CO2, with hydrogen fuels, and it's a primary source to transport hydrogen within pipeline systems or within the logistical system and trucking. Without CO2, it makes developing hydrogen a bit more difficult and utilizing it a bit more difficult. So it's depending on the market, these secondary products can be very valuable, and if not as valuable as the primary source that you're generating when it comes to revenue.
I saw the other day that the CO2 shortage is affecting the craft beer industry, which is running out of CO2 for carbonating its beverages. So that is a major societal driver, right? You got to make sure we're producing enough craft beer. All right. Perry, I'm sorry to do this. You mind talking through these? You're better at this stuff than I am.
Oh,
Yeah,
no,
that would
not
be
at all.
that would be a horrible thing. Like if we don't have craft beer, right?
Yeah, it'd be horrible. Yeah.
So what are RECs is what we typically talk about in our sector. They're renewable energy certificates, which are basically tradable, non-tangible energy commodities that represent proof of 1 megawatt hour of electricity that was produced using renewable resources. Those renewable resources could be RNG, basically non-fossil based, that were utilized to generate electricity. Many states have developed renewable energy portfolios to promote green green electricity, green and renewable energy sources. And as such, it mandates its electrical utility providers to purchase a percentage of their needs through these RECs. And in some states, this is mandated, and in other states, it's voluntary through the ESG goals that the organizations put together. We're seeing companies such as SoCal and PG&E. They are in a market that requires them to purchase a number of their megawatt hours from green sources. And then in other markets such as Colorado and I want to say New Mexico, Xcel Energy is purchasing a number of their percentage of their electricity that they're providing to their end users because of the ESG goals that they have, and it's not necessarily mandated. So depending on where you are in the country, there's different regulations, but there are some states that have a renewable energy portfolio, and with that comes a requirement to the utility companies that they have to utilize renewable resources such as wind, solar, and power generated through RNG in their portfolio.
And one of the things that we've seen, there's another mechanism, there's like Perry was saying, there's state goals and there's ESG goals. We've also seen, like with some providers that haven't been very progressive, activists and investors have actually come in and got seats on board and promoted these types of ESG goals to make companies like Tri-State improve their renewable energy portfolio. So that's been another driver for this is actually activist investors. You want to keep talking about these, Perry?
Sure, absolutely. We have a federal policy known as a renewable fuel standard, also renewable identification number known as RINs, that was enacted by Congress in 2005 and amended again in 2007, that essentially incentivizes development of low carbon fuel or renewable fuel within our system, and RNG certainly falls under that. It basically provides additional financial benefits for a unit of energy that's produced that qualifies, and it increases the value of gas, particularly with RNG, depending on how it's classified. So with RINs, or renewable identification number, depending on what source of organic material that you use, there is different values that can be associated with the amount of methane that's produced. And different RIN numbers drive different values, but overall, renewable fuels are typically higher in value and in comparison to their counterpart that's derived from fossil-based fuels.
Yeah, thank you. Let's see, I'll take a couple and give you a break here. So we have several states have basically created complementary programs to the renewable fuel standard that was produced by the federal government. And those are also just focused on reduction of the fossil-based fuels in their state. In particular, California and Oregon have LCFS and clean fuels incentive programs. And those credits are stackable. So you can basically claim credits in both programs on qualifying projects, and that further increases the value of the gas. And I guess I'm more familiar with the California one than the Oregon one, but correct me if I'm wrong, Perry. Basically, what you have to show is that there's a pathway for the molecule of gas that you're producing, that somehow it can get to California. It doesn't actually have to be there. You just have to show that in theory it could get there, and that allows you to claim the credit.
That's absolutely correct. We have a vast pipeline system in the United States where we trade from destination to destination, a certain number and volume of gas, and really this is more of a contracting term. Gas is gas, but if you're showing that you're selling to an end user in California, essentially you inject your gas that you've produced into a pipeline system, And on the other end, if there's truly a pathway, the end user will collect the same number of units of gas. It may not be exactly the same molecules, but they'll collect the gas. And essentially, it's a mass balance. You're putting a percentage of RNG within the system, and you're pulling it out of the system on the other end. It truly is a commercial agreement than a trade molecule for molecule.
Yeah.
Hey guys, just a question, like what is the state of the RNG vehicle industry? Like if they are actually, I didn't even know about this incentive that the feds provide, but if people take them up on the offer and start generating like RNGs for like vehicles, are there enough vehicles like in the market to actually absorb the demand?
So go ahead, Perry.
Go ahead.
Well, I'm just going to give my local example where, like in Gunnison, small town where I've lived, we have a bus fleet that basically runs around town and takes people up to the ski area also, and it's free. It's funded by the ski area, and they've switched to RNG. So I think what you find is for those types of fleet-driven operations, they're pretty economical, and again, driven by, you know, the sustainability goal of the entity. Do you have something to add to that, Perry?
We are seeing a large shift in commercial vehicles transitioning to compressed natural gas. We know of this practice in Asia, particularly, and India. That's been in play for decades. It's starting to catch on in the United States as well. Waste Management and Republic, they've transitioned. They're large waste organizations, waste management organizations that have transitioned their fleets to renewable natural gas. And previous to that, just compressed natural gas is a cleaner fuel, reduces emissions in the air, and that's their way of contributing to reducing their emissions and reaching their sustainability goals as well.
Great, thanks.
So carbon offset credits, so these occur in some voluntary markets in the US, and they can be earned by reducing greenhouse gas credits, such as methane recovered from these projects from anaerobic digestion or biogas systems. These credits have some economic value and can be bought and sold on the commodity exchanges, or through private transactions or through credit aggregators. So Perry, do you have anything you want to add to that?
I do know the state of California, they have a target, I believe it's by 2030, that 100% of the electricity utilized in the state of California is coming from renewable resources. And with that, there's a transition that's taking place with a number of power plants. There is a step down process that's taking place and reducing emissions. In these states, because it's a cap and trade, obviously, and it's happening so rapidly, I would say that the value of carbon credits becomes greater in such states and is traded at a higher value compared to, let's say, Texas, that doesn't have such strict, stringent regulations. We also have seen that the IRA, the Inflation Reduction Act, calls for the EPA to set new emission standards within the next 17 months now. So we expect that many industrial facilities will have lower emission standards. And as some of these industries struggle to reduce and meet those standards, they will be looking to their counterparts, such as water and wastewater facilities, and other industrial applications that are utilizing RNG or the production of RNG to lower their carbon emissions. They're going to be looking to them to purchase those credits if they're unable to lower their emissions within the timeline that's dictated by the EPA come next year.
So that's an alternative to reducing their emissions, is purchasing.
Short term, yes.
Short
term, correct.
They need more time.
Exactly. It's a cheaper, let's say if capital is a constraint, they can purchase the credits for a lesser nominal value and not be penalized and have to pay fines in addition to potentially carbon taxes that are also being proposed right now.
Are there like regional markets? I mean, you mentioned state markets like California and Texas. Are there regional markets like in the Northeast or the Midwest where states have kind of gone together to create a commodity pool for these?
It's certainly, I would say, the more greener the state, the value is greater. The New England states and West Coast definitely. Outside of that, I think it's catching on, but it's slower. Obviously, if it's federally mandated, we'll definitely see a shift in that space within all states. The carbon taxes being proposed right now will definitely have a dramatic effect in the industry across the United States.
Cool. You want to talk through this one, Terry? You're probably, did I skip a couple? Whoops.
Sorry, Dave, I lost you.
I'm sorry. I thought I might have skipped some slides, but I guess I didn't.
This is, I think we spoke about this. Essentially, when you're producing RNG, depending on what your offtake contract is and where the destination of the molecules are, you can utilize the federal programs and buckle in state programs as well to truly increase the value of gas. In some states, we're seeing that the unit of gas is being sold for $80 to $120 when regular natural gas is being traded at $3.50. So you can definitely see the drivers there and the incentives that are pushing for the development of RNG.
Thank you. So just to kind of recap, some of the revenue sources. So we got the direct sale of the biogas. We got the tax credits, the renewable energy credits, the renewable fuel standard, carbon offset credits, potential organic byproducts, potential fertilizer, nutrient enhancement materials, and potential tipping fees. So all those are things that can be economic drivers for the renewable natural gas project, as opposed to just, as Perry mentioned earlier, just selling the gas or the energy itself.
Absolutely. Just speaking to tipping fees, when we think of tipping fees, basically dumping waste, a lot of organizations now are transitioning from dumping their organic waste in landfills to trying to find an outlet like an RNG facility where they can do so at a cheaper rate. I would say that we had a client on the municipal side that was paying $16 million a year to dispose of their biosolids. And here we're looking at this as that's a valuable feedstock that can produce RNG. So offering a discount for a tipping fee at half that amount still saves a particular municipality a great number of operational costs, but in return, you're also gaining feedstock that produces a valuable product as well. So there's definitely great incentives that can come from truly utilizing your anaerobic digestion facility